Alright, so here we're going to learn how to control something. This is really an important um, topic here called pulse width modulation. I mentioned it in the last video. Pulse width modulation, if you do a quick Google on it, you'll get something like this. And here's a pretty good kind of general idea with it. The main kind of premise is we want to cycle something instead of changing its voltage. So changing the voltage would change the height of these kind of spikes here, but pulse width modulation, what it's going to do is change how wide the on and off cycles are. So you can see here that the duty cycle is how long it's going to stay on, and you have a certain period or a number of duty cycles per um, second probably, and that's going to be the frequency. And so for that for now. So the idea is what we want to do is we want to control the voltage or the brightness of an LED based on the user input. So we're going to use the potentiometer. Sorry, and we're going to use that potentiometer not to adjust the voltage, but to adjust the duty cycle in general. So the setup I have here is actually both of those situations. This one is the LED we were looking at before that's coming straight out of the potentiometer and the voltage. So the voltage coming from the potentiometer is going to directly affect the LED here, and that's going to change the brightness. You'll notice with this one, though, it doesn't turn on until we get to like 1.7 volts, and then it'll start to turn on. This one is the one where we will use the PWM setup, and it's on now. So the potentiometer is all the way down to about zero, 320 volt or 0.3 millivolts or something like that. I don't know. Sorry. But you can see that it's got a signal because it is being past a duty cycle that's not zero. So we can set this to pin y dot duty cycle equals 0 for now. And if we save that, we can see that that LED now completely turns off. The yellow one does. So if we turn the loop back on again, actual Boolean value now, we can start to see that the LED is back on again, very, very dimly for me. I know it looks brighter in the video, but if we start to change the potentiometer, you'll see that it gets brighter very quickly. And the red LED, because it's based on voltage directly, is just now starting to turn on. And we're right at kind of the halfway point for the potentiometer. So now the red LED light will turn on, and the duty cycle for the yellow LED is such that from about halfway or a third of it in, you can't really see any brightness change because it's kind of already flickering so quickly. So that's what the big difference is between pulse width and just a straight voltage. Because even an LED that normally turns on around 1.7 volts can turn on with pulse width modulation just very dimly because it's getting the full 3.3 volts sometimes. It's getting a very small spike in this situation where it does turn it on, but it's mostly off, and so it's therefore really dim. So the way that pulse width modulation works is you define your pin variable. You give it the board pin. GPIO 11 is this I don't know, fifth or sixth pin in from the end here, and you give it a frequency value, which is how fast it's going to turn on and off. I think if we turn this like way down, Well, if it's got a minimum. Yeah. Yeah, you can actually see it flickering now. And so then if I turn it up, you'll see that the amount of time that the flicker stays on speeds up. And so now it's all the way up. And so it's just on permanently. So that actually is a really helpful way to look at pulse width modulation, because as I turn this down, the on and off gets less and less. And that's why it dims. You could just probably change this to 1 hertz. Yeah, so you can really see it flashing there. But the flashing is because it's on for a bit and off for a bit. And but how long it's on and how long it's off is what we're modifying with the duty cycle value that we're taking from the potentiometer. So I'm almost all the way up, and you can kind of see on the video that it's flickering. I can see it a lot more in real life. And then if I go just a tiny little bit more, it's just on. So that's what pulse width modulation does. Now, this doesn't just work for LEDs. This is how you modify or make motors spin at certain rates. And there's a thing called a piezo. And check and see, I'm pretty sure we have one in the kit. And that would allow us to make sounds. So I'll be right back. Let me see if we can find that. Okay, I was just looking through the electronics list, and the piezo does not look like one of the items that we have, but there is a passive and active buzzer. So we'll probably try playing with that here soon. All right, so with that being said, that's how you do pulse width modulation. The code for it is very quick and easy, and allows for some cool abilities with things like LEDs, and eventually we'll get into motors and those kinds of things, driving them with PWM. All right.